Hello friends, welcome back to my YouTube channel. This is part number 3 of my discussion on drawing, and in this I will be discussing 3 numerical examples that are based on my discussion in part number 2. So I hope you have seen part number 2. I'm giving link to the entire playlist of my video lectures on drawing in the description section. So in these numerical examples, we will learn how we can convert moisture content on wet basis to moisture content on dry basis. And then we will learn how to find quantity of moisture removed in a typical drying operation. And we will also know how you can find quantity of dried product. So the numerical examples that I am going to discuss in this video lecture will help you learn how to get or how to convert moisture content on wet basis to moisture content on dry basis, how to find quantity of moisture removed in a drying operation, and then how to get quantity of dried product. So let us begin the discussion. So first let us talk about numerical number 1. The statement goes like this: a wet solid is containing 85% moisture and it is dried to reduce the moisture content to 22%. Calculate the quantity of moisture removed per 1000 kg of dried product. So we have wet solids we have a wet solid that is containing 85% moisture in it, and the task is to reduce this moisture content to 22%. Now, since they have said nothing about the type of moisture content, that is whether it is on wet basis or dry basis, so if that is the case, we have to consider the given moisture content on wet basis. So, moisture content of the solid is given on wet basis. Then we have to calculate the quantity of moisture removed per 1000 kg of dried product. So in this case, we know the quantity of dried product that is to be obtained, and for that case, we need to find out the quantity of moisture removed for producing 1000 kg of dried product. So let us list what is given to us in this numerical statement. So initial moisture content, it is given to us, it is on wet basis. So I will call it as Xi. Percentage Xi is given to us initial. So percentage Xi is 85. Then I can convert it to fraction by dividing with 100. So Xi is 85 upon 100, that is 0.85. Then final moisture content is given to us percentage Xf. I'll call it as Xf. So percentage Xf is given to us, it is 22. So we can convert it to fraction by dividing with 100. So Xf is 22 by 100, that is 0.22. Then quantity of final dried product, it is given to us. Let us denote it as P. So P is 1000 kg and it contains 22% moisture. So that is the information that is available to us, the final moisture content. Again, this moisture content is on wet basis. Then what are we supposed to find? We have to get the quantity of moisture removed in this operation. So I hope the given information is clear to you. If you have any doubt, you can mention that in the comment section. Let us move on. Let us first understand the approach to solve this. First, we will be converting Xi, small xi to capital Xi. That is moisture content on wet basis to moisture content on dry basis. So we will be converting small xi to capital Xi and small xf to capital Xf. And how are we going to do that? We will be doing it by using the relation that is known to us, a relation between small x and capital X. That is the relation between moisture content on wet basis and moisture content on dry basis. Then after that, we will find kg of moisture removed per kg of dry solid. And after we get that, next we will be finding kg of bone dry solid in the solid that is given to us. And finally, we will find the total kg of moisture removed. And how are we going to get that? We are going to get that by multiplying the kg of moisture removed per kg of dry solid with the kg of dry solid. So once you get moisture content in the kg of moisture removed in kg per kg dry solid, then if you multiply with kg dry solid, you are going to get the kg of moisture that is removed. So in this way, we will get the final answer for this numeric. So let us move ahead. Now let us start solving this numerical. First, we will convert small xi to capital Xi. For that, we know small xi and capital Xi, that is moisture content on wet basis and moisture content on dry basis, they are related as capital Xi is equal to small xi upon 1 minus xi. Small xi is 0.85. Therefore, capital Xi will be 0.85 divided by 1 minus 0.85. So, therefore, capital Xi will be 0.85 divided by 1 minus 0.85 is 5.67. So, it will be 5.67 kg of moisture per kg of dry solid. Now, let us convert small xf to capital Xf. For that, again, small xf and capital Xf, they are related to each other by this equation. Capital Xf is equal to small xf upon 1 minus small xf. Small xf is 0.2. So, therefore, capital Xf will be equal to 0.22 divided by 1 minus 0.22. So, that gives us capital Xf as 0.282. Again, it is kg moisture per kg dry solid. So, in this way, we get moisture content, initial moisture content on dry basis. It is 5.67 kg moisture per kg dry solid, and final moisture content on dry basis, it is 0.282 kg moisture per kg dry solid. Let us continue. Then let us get moisture removed per kg dry solid. So how are you going to get that? It is calculated as, let us denote it as delta capital X. So it will be capital Xi minus capital Xi. So initial moisture content on dry basis minus final moisture content on dry basis will give us moisture, kg of moisture removed per kg of dry solid. So capital Xi is 5.67 kg moisture per kg dry solid. Capital Xf is 0.282 kg moisture per kg dry solid. So therefore delta X will be equal to 5.67 minus 0.282. So that gives us delta X as 5.388 kg moisture per kg dry solid. So in this way we get kg of moisture removed per kg of dry solid. Then let us get kg of bone dry solid. So for that we are going to use this information. The final dried product, it is containing 22% moisture in it. So therefore kg of bone dry solid in it, that will be given as we denote the mass of bone dry solid by MDS. So MDS will be equal to 1 minus small xf into P. Small x is percentage moisture. So 1 minus small xf will be percentage bone dry solid in it. So that's why MDS is equal to 1 minus small xf into P. So small xf is 0.22, capital P is 1000 kg. So therefore MDS will be equal to 1 minus 0.22 into 1000. That gives us MDS as 1 minus 0.22 is 0.78. So 0.78 into 1000. So that gives us MDS as 780 kg. That is 780 kg. So in this way we get kg of bone dry solid. Let us continue. Now let us find total moisture removed. So it is calculated in this way. Let us denote mass of moisture by capital M. So capital M will be equal to delta X into MDS. So delta X is kg moisture removed per kg dry solid. and MDS is kg dry solid. So kg dry solid will get cancelled, and you are left with kg moisture removed. Total kg moisture removed. So delta X, we calculated it earlier, it is 5.388 kg moisture per kg dry solid. MDS, we also calculated it, it is 780 kg. So therefore M will be equal to 5.388 into 780, that is M is equal to 4202.64 kg. So this is the total amount of moisture that is to be removed in this operation, and that is the final answer for numerical number Y. So I hope you have understood the steps that I have used in solving this numerical. If you have any doubt, you can mention that in the comment section. Let us move. Okay, now let us solve the second numerical. The statement is like this: a wet solid weighing 500 kg contains 70% moisture. It is to be dried so that the final dried product contains 15% moisture. Find the amount of moisture that needs to be removed in this drying operation. So, in this case, we have a wet solid whose weight is given to us. That is, we know weight of wet solid. It is 500 kg. And it is containing 70% moisture. So, this is moisture content on wet basis. Now, it is to be dried so that the final dried product, it contains 15% moisture. So, again, this moisture, it is given on wet basis. So, based on this, we have to get the final amount of moisture that needs to be removed in this drying operation. So, let us first list what is given to us. So, mass of the wet solid, it is given to us. Let us denote it as MWS, it is 500 kg. So, initial moisture content, it is given to us. That is percentage XI is given to us, small xi, that is moisture content on weight basis. We can convert it to fraction. So, small xi will be 70 by 100, that is 0.70. Then final moisture content, it is given. So, percentage XF, it is 15. So, therefore, small xf is 15 upon 100, that is 0.15. Then what are we supposed to find? We have to get the quantity of moisture that is removed in this operation. Let us continue with this. Let us first understand the approach. We will convert small xi to capital Xi and small xf to capital Xi, as we did it in the case of numerical number 1. And we will be doing it by using the relation between small x and capital X. Then we will find the kg of moisture that is removed per kg of dry solid. Then we will find out kg of bone dry solid. And finally, we will find out the total kg of moisture removed. And we will be doing it by multiply kg of moisture removed per kg of dry solid with kg of dry solid. So that will give us total kg of moisture that gets removed in this operation. So let us move on. So let us solve it. So first let us convert small xi to capital Xi. Small xi and capital Xi, they are related by this relation. Capital Xi is equal to small xi upon 1 minus small xi. Small xi is 0.70. So therefore capital Xi will be 0.70 divided by 1 minus 0.70. So that is capital Xi comes out to be 2.33 kg moisture per kg dry solid. So in this way we get capital Xi. Then let us convert small xf to capital Xf. So small xf and capital Xf, they are related in this way. Capital Xf is equal to small xf upon 1 minus small xf. Small xf, it is given to us, it is 0.15. So therefore capital Xf will be equal to 0.15 divided by 1 minus 0.15. That gives us capital Xf as 0.176 kg moisture per kg dry solid. So in this way we get initial moisture content on dry basis 2.33 kg moisture per kg dry solid, and final moisture content on dry basis, it is 0.176 kg moisture per kg dry solid. Let us move it. Now let us find out moisture removed per kg dry solid. So it is calculated as delta X is equal to delta capital X is equal to capital Xi minus capital XF. Capital Xi is 2.33 kg moisture per kg dry solid. Capital XF is 0.176 kg moisture per kg dry solid. So therefore delta X will be equal to 2.33 minus 0.176. That gives us delta X as 2.154 kg moisture per kg dry solid. Then let us get kg of bone dry solid, and for that we are going to use this information. The wet solid contains 70% moisture in it, and therefore kg of bone dry solid in it, it is given as MDS is equal to, so if small xi is moisture content on weight basis or moisture in it, then 1 minus xi will be the bone dry solid. So MDS will be equal to 1 minus xi into MWS. MWS is known to us. So xi, small xi is 0.75, fraction of moisture in the initial fraction of moisture in the wet solid. MWS is given to us, it is 500 kg. So therefore MDS will be equal to 1 minus 0.7 into 500. So that is MDS is equal to 0.3 into 500. That gives us MDS as 150 kg. So kg of bone dry solid is 150 kg. So let us continue with this. Now let us find total moisture removed. So it will be calculated as M. Let us denote the total moisture by capital M. So M is delta X into MDS. Let me just talk about this, how this equation comes into picture. So delta X, it is kg moisture per kg dry solid. Per kg dry solid. And we are going to multiply it with kg dry solid. Kg dry solid. So in this case, kg dry solid gets cancelled and we are left with kg moisture. So that gives us total moisture, total kg moisture that is removed in this operation. So I hope you have understood this. So let us use the values that are known to us. Let me just erase it first. So therefore, delta X is 2.154. We calculated it earlier. Kg moisture per kg dry solid. MDS is 150 kg. We calculated it earlier. So therefore, M will be equal to 2.154 into 150. That is, M will be equal to, that comes out, that gives us M as 323.1 kg. So that is the final answer for numerical number 2. So where we get the total kg of moisture that gets removed in the operation. So that ends our calculations for numerical number 1. So I hope you have followed the steps that I have used for solving numerical number 2. If you have any doubts, please mention them in the comment section. Let us move. So now let us solve numerical number 3. So we have a dryer that processes 200 kg per hour of wet material containing 40% moisture on wet basis. Find the rate at which the dried product is produced if it is to contain 5% moisture on wet basis. So in this case, you have a continuous operation where the dryer is processing 200 kg per hour of wet material. So quantity of material processed, quantity of wet solid processed per hour, it is given to us. It is 200 kg per hour. And the moisture content of that solid, it is given to us. It is 40% moisture on wet basis. Then with this information, we have to get the rate at which the dried product is produced if the dried product is to contain 5% moisture on wet basis. So let us first understand what is given to us. So you have the dryer. Feed is given to us. The feed is given to the dryer. feed is nothing but 200 kg per hour of wet material that is containing 40% moisture on weight basis. And we will be getting a product that will be containing 5% moisture in it. 5% moisture on weight basis. So for the feed, we know the feed rate, that is F is given to us, it is 200 kg per hour. The moisture content is given to us. So let us denote it as XF. Here XF stands for the moisture content in the feed. So I have used this notation. You can use a different notation, no problem. So percentage XF is given to us, it is 40. So we will convert it to fraction. So therefore XF will be equal to 40 upon 100, that is 0.4. Then for product, the moisture content is given to us. It is, I will be denoting it as XP, moisture content in product. So percentage XP is given to us 5. Both the moisture contents are on weight basis. So therefore small XF and small xp. So therefore small xp will be equal to 5 upon 100, that is 0.05. And what are we supposed to find? We have to get the rate at which dried product is produced. So that is, in this case, we have to get P. We have to find out P. So the approach would be, first we will converting XF, small xf to capital XF and small xp to capital XP by using the relation between small x and capital X as usual. We have been doing it in this discussion. Then we will be finding kg of dry solid in the feed. Then we will be finding P, the rate at which dried product is produced, by using kg of dry solid and moisture content in the dry product, because both will be known to us at this point of time, and that will be the final answer. Okay, so let us start solving this. First we will convert small xf to capital XF by using the relation between small xf and capital XF. So capital XF is small xf upon 1 minus small xf. Small xf, it is given to us, it is 0.40. So therefore capital XF will be equal to 0.40 divided by 1 minus 0.40. That gives us capital XF as 0.67 kg moisture per kg dry solid. Then there is no need of converting, because we will not be using XP. So that's why I am not converting small xp to capital XP. Let us directly get kg of bone dry solid in the feed. And how are you going to get it? So FDS, let the rate of bone dry solid in the feed, let me denote it as FDS. So FDS is 1 minus small xf. XF is fraction of moisture in the feed. So 1 minus xf will be 1 minus xf will be the fraction of bone dry solid in it. So therefore FDS is equal to 1 minus xf into F. So XF is given to us, it is 0.40. F is given to us, it is 200 kg per hour. So therefore FDS will be equal to 1 minus 0.4 into 100 into 200. So that is FDS is equal to 1 minus 0.4 is 0.6. So it is 0.6 into 200. So that gives us FDS as 120 kg per hour. So in this way we get kg per hour of bone dry solid in the feed, and it will remain unchanged. The same quantity of bone dry solid will be coming out with the product. Let us find P. So the final dried product, it contains 5% moisture on weight basis. We are going to use this information. So in other words, it contains 95% bone dry solid. Kg of bone dry solid, it is already known to us, because whatever it is in the feed, the same will remain in the product. So FDS will be equal to 1 minus XP into P. So FDS, it is known to us, bone dry solid, and in the product it is 1 minus XP. XP is known to us, into P. We have to get P. So therefore XP is given to us, it is 0.05. FDS, we calculated it earlier, 120 kg per hour. So let us use this information. So 120 is equal to 1 minus 0.05 into P. So that is 120 is equal to 0.95 into P. That is 120 divided by 0.95, that is equal to P, and that gives us P is equal to 126.32 kg per hour. And that is the final answer. This is the rate at which dried product is produced. So that ends our calculation for numerical number 3. And that ends my discussion for this video lecture. So I have solved 3 simple numericals in this video lecture to help you understand how you can find the quantity of moisture that you need to remove in any drying operation. And then you have, or you also know how to find the kg of dry product that that is produced in any drying operation. So these 3 simple numericals will help you understand how this is done. So I hope you have understood all the 3 numericals and the solutions to all the 3 numericals. If you have any doubts, please mention that in the comment section. Thanks for watching this video lecture. Do subscribe to my channel, tell your friends to subscribe to it, hit the bell icon so that you will be notified as soon as I upload any new video on my YouTube channel. In my next video lecture, I will continue my discussion on drying of wet soap. Till then, have a nice day. Bye bye.